So some of you, this may be all review. Some of you, this may be part new, part old. So basically, let's talk about completing the square first. In Algebra 2 and Algebra 1, you studied a lot of different ways to solve a quadratic equation. When I say a quadratic equation, how do you know it's a quadratic equation? What's the degree? What do you look for? It has an x to the what? X to the second, exactly. Remember, so anytime you're looking at a quadratic equation, you're looking at an equation in the form of y is equal to ax squared plus bx plus c. So that's what we talk about in quadratic equations. And back in Algebra 1 and Algebra 2, you have a lot of different techniques or tools you can use to help you figure out how to solve a quadratic equation. Generally, we always try to factor first. So factoring is one way we try to solve a quadratic. You can isolate the square, which means you then take the square root of both sides of the equation. You also have the quadratic formula. So those are three ways you can solve the quadratic. There's another way, which I personally like over quadratic formula in certain cases, which is called completing the square. There's actually a lot of other applications that if you go on to calculus, you will use completing the square for a lot of other things besides just solving quadratic equations. There's a lot of other applications for completing the square besides just solving equations. Now, just a quick review here. When you see a binomial to the second power, a very common algebra error is just to write x squared plus 64. That's a big no-no. When you see x minus 8 to the second power, remember what that means is you're taking x minus 8 and you are multiplying it by itself. Remember, you never distribute an exponent inside a set of parentheses with a plus or a minus. You have to do your FOILing. So when I multiply x minus 8 times x minus 8, that gives me an x squared. My outer term is a minus 8x. My inner term is a minus 8x. That's a minus 16x plus 64. So just remember, anytime you have that binomial to the second power, you never, ever, ever distribute an exponent inside parentheses with a plus or minus. You've got to FOIL it and multiply it out. So then x plus 3 to the second power would be x plus 3 times x plus 3. So again, that's going to give me an x squared. Outer terms are 3x. Inner terms is 3x. That's going to be a positive 6x. And then my last term is 3 times 3 is 9. And then lastly, again, remember, x minus 12 to the second is x minus 12 times x minus 12. So that gives me an x squared minus 12x minus 12x is a minus 24x. And then what's 12 times 12? 144. So just remember, when you see those powers, those binomials to the second power, you don't distribute it, right? Just exact. You're always going to have the three terms. There is a special name we have. When we multiplied out these three binomials, we do have a special name for these trinomials. They are called a perfect square trinomial. So when you do have a binomial to the second power and you multiply it out, it creates something called a perfect square trinomial. And a perfect square trinomial, look at where it came from. It came as a binomial square. So like an a minus b to the second power. So what's nice about a perfect square trinomial is the fact that when you factor a perfect square trinomial, you factor it into a binomial to the second power. And that's kind of the foundation or the basis of what we do with completing the square. So the way we will solve quadratic equations is we are actually going to create a perfect square trinomial that we could factor into a binomial to the second power. So first of all, with completing the square, you always want to make sure that the coefficient of x squared is a 1. If it isn't, we're going to divide by that coefficient. We're going to make sure that we keep our x squared and x on one side, move the constant to the right side. So what happens is this is the process for completing the square. We take half the coefficient of x, and then you square it, and we add it to both sides. So for example, up here, the coefficient of x in my generalization is just b. So what we do is we're going to take the coefficient of x, which is b, divide it by 2, and square it. So that is the formula that we will use. That's going to give us the number that's going to create the perfect square trinomial. And then we're going to have to keep our equation in balance, and we're going to add it to both sides. Once you factor it, which you should be able to because you've created a perfect square trinomial if you've done everything correctly, you'll be able to factor it into that binomial squared, and then you'll be able to solve the quadratic. All right, so for example, let's take a look at the first one. So x squared plus 10x plus 24 equals 0. Again, there's more than one correct way or method you could use to solve quadratic equations. So for example, if I want to use completing the square, the first step is you always want to take your constant, which is positive 24, and move it to the right side. So that's always your first step. You always want to make sure your x is on one side of your equal sign, your constant's on the other. So that's always your first step. Now what you do is you're going to take half of 10. So we're going to take whatever number's in front of x. We're going to divide it by 2, and we're going to square it. So what is 10 divided by 2? 5. And then what is 5 squared? 25. That's the number we're going to add to both sides of the equation. All right, so any questions where I got the 25 from? Again, you have to keep your equation in balance, remember, so I just can't add 25 to one side, I have to add it to the other. So now, notice what I have on the left-hand side. I should have a perfect square trinomial that I can factor. So how can I factor x squared plus 10x plus 25? What are my factors of 25 that add together to give me 10? 5 and 5. So I could write this as x plus 5 times x plus 5 equals, what is negative 24 plus 25? 1. What's another way to write x plus 5 times x plus 5? X plus 5 squared. Now we're going back. You guys have solved equations like this back in Algebra 2. We want to solve for x. How do you get rid of the square? What are you going to do to both sides of the equation? Square root it. And remember, when you square root it, what do you have to remember to put in front of the radical? Plus or minus 1. So now how do you solve for x? What do you do to get x by itself? Subtract 5. So x is equal to negative 5 plus or minus 1. Remember what this plus or minus means. How many solutions do you have here? 2. So remember, one is negative 5 plus 1. The other is negative 5 minus 1. So what are your solutions then going to be? What is negative 5 plus 1? Negative 4. Negative 5 minus 1 is negative 6. So your solutions are negative 4, negative 6. I like this in certain cases of a quadratic formula because you guys can do quadratic formula well as long as you're just plugging in the numbers. Where a lot of you run into trouble with quadratic formula is you've got to then deal with simplifying a radical, which I know a lot of you don't like, and then you've got to simplify a fraction, which some of you like to chop your heads and tails off animals. So you have issues simplifying. Completing the square gives you a much more simplified answer where you don't have to worry about simplifying radicals necessarily and fractions all at the same time. So that's why completing the square gives you a much more simplified answer. All right, let's take a look at number 2. X squared plus 4x minus 1 equals 0. When I would choose completing the square or quadratic formula any day, it's when the number in front of x squared is a 1 and the number in front of x is an even number. That's where any day I would choose completing the square or quadratic formula. So now, the way completing the square works, what's going to be my first step? What do I have to do with this minus 1? I have to move it to the other side. So I have x squared plus 4x. So what I do is I always like to draw a blank right there. Equals 0 plus 1 is 1 plus, and I put another blank. That's a reminder to me that I'm going to have to add something to both sides of the equation. All right, so any questions on what I've done so far? So now to figure out what number I have to add here to create the perfect square trinomial is I'm going to take the number, it's always the number in front of x. So I'm going to take 4, divide it by 2, and square it. So that's always the formula for completing the square. And what's 4 divided by 2? 2. And then 2 squared is 4. So I'm going to add 4 on the left, 4 on the right. So now you should have on the left-hand side a trinomial that you can factor. So what are your factors of 4 that add together give you 4? 2 and 2. So I could write this as x plus 2 times x plus 2, or write it as x plus 2 to what power? Squared. Equals 1 plus 4 is 5. Any questions so far? So now, how do you start solving for x? What are you going to do to both sides of the equation? You're going to take your what? Square root. So I have x plus 2 is equal to, again, don't forget what you have to add in front of your radical, plus or minus. So now what's x going to be equal to? X is equal to what? -2 plus or minus square root of 5, correct? Remember, you always write, when you're writing these problems, yes, you could write plus or minus square root of 5 minus 2. However, my advice to you is it's not going to be in here. Everybody in here has beautiful handwriting. But some of your handwriting may not necessarily be the neatest. So this way, sometimes it's hard, you know, you're in a rush, you may make your radical sign a little bit longer. Sometimes it accidentally appears that it looks like the minus 2 should go to the radical. That's why you always put the constants in front of the radical, so you clearly know that the -2 is not under the radical sign. Now remember, how many solutions do you have sitting here? 2. You have -2 plus square root 5, -2 minus square root 5. Just remember that that plus or minus means you have 2 solutions sitting there. All right? I mean, yes, you can write plus or minus, but just remember there's actually 2 solutions there. How many of you guys remember doing this in last year? Like I said, a handful of you, like I said, this is a little bit of new in this section for some of you. All right? But like I said, imagine what simplifying you would have to do with quadratic formula to get it down to -2 plus or minus square root 5. You would have had to simplify this radical down to a square root of 5. There would have been a number in front, and then you would have had to simplify a fraction. That's what I mean. Completing the square gives you a much more simplified answer than the quadratic formula. All right? Let's look at another one. So x squared plus 6x minus 10. What's the first step here? What are we going to have to do first? Add 10. So I have x squared plus 6x. Again, I'm going to put a blank there, equals 10. And again, I'm going to put a blank on that side. Again, that blanks help to visually remind you to add a number to both sides of the equation. So now, to figure out what number I'm going to add here to create a perfect square trinomial, what am I going to do with the 6? I'm going to take the 6 and do what? Divide by what? 2. And then what do? Square it. So 6 divided by 2 is 3, and 3 squared is what? What's 3 squared? 9. So I add 9 on the right, add 9 on the left. So now, like I said, you now should have a trinomial that you can factor into a binomial squared. What are your factors of 9 that add together give you 6? 3. So I can write it as x plus 3 times x plus 3, or x plus 3 to the second. Equals what? What is 10 plus 9? 19. Now notice, when you factored it, you told me we factored into x plus 3. Notice the 3. What number did you end up squaring? 3. Look at the last example. When you factored, we factored into x plus 2 times x plus 2. What number did you end up squaring? 2. Back here, in the very first example, we factored it as x plus 5, x plus 5. What number did you end up squaring? 5. All right, that's not a coincidence, so it'll always happen. All right, I'm bringing that to your attention because it's going to help us in the next one a little bit. All right, so now how do you solve this? What are you going to do to both sides of the equation? Going back to example 3. Square root. So we have x plus 3 is equal to plus or minus the square root of 19. So now how do you finish solving for x? You're going to do what? Subtract the 3. So x equals -3 plus or minus square root of 19. Okay? So any questions on that example there? Like I said, completing the square works when the coefficient of x is an even number and the leading coefficient is a 1. But you can still do it even if the coefficient of x is an odd number. All that means is you're going to have a fraction as part of your answer. What equals that? It's 19. Because it's 10 plus 9. Remember you added the 10 on the right-hand side? And then you had to add 9 to both sides of the equation. So that's where we got 19. Because remember, it was a minus 10, but you have to add 10 to both sides. So like I said, completing the square still works, even if the coefficient of x is an odd number. It's just you're going to end up with a fraction as part of your answer. So what are we going to do first to start completing the square? What do we have to do with this minus 1? Add 1. I'm going to leave a blank here, equals 1 and then a blank. So now, completing the square, we take the coefficient of x, we divide it by 2, and we square it. So when you square a fraction, remember you have to square the numerator and the denominator. So what is negative 5 over 2 squared? 25 over 4. So I'm going to add 25 4 on the left, and I'm going to add 25 over 4 on the right. Now this is why I brought to your attention, I know I'm going to have to factor the left-hand side into a binomial to the second power. That's why I kind of highlighted the last 3 examples. When we factored, notice when we factored those binomials, that number that we squared ended up inside the parentheses. So look here, what value did I end up squaring to get the 25 over 4? Negative 5 fourths. So guess what's going to go inside my parentheses when I factor it? Negative 5 fourths. It's going to be x minus 5 fourths. Oh yeah, 5 over 2. Just make sure you guys are awake. So now what is 1 plus 25 over 4? 29 over 4. So any questions, even if you have that odd number in front of x, what's just going to happen is you end up with a fraction. But don't panic when you go to factor it. Look at what value you squared. Look at the fraction you squared. That's what goes inside the parentheses. Now how do you get rid of the square? What are you going to do? You're going to take the what? Square root. So I have x minus 5 halves is equal to plus or minus the square root of 29 over 4. Now look at this fraction under a radical. Remember your quotient property of radicals. You can take the square root of the numerator, divide it by the square root of the denominator. What is the square root of 4? 2. So this fraction is equivalent to the square root of 29 over 2. So I have x minus 5 halves is equal to plus or minus the square root of 29 over 2. Now how do you finish solving for x? What are you going to do? Add 5 halves. So 5 halves plus or minus the square root of 29 over 2. Yes, you could write this as one large fraction if you wanted to. This is equivalent to 5 plus or minus square root of 29 all over 2, which that looks a lot like a quadratic formula answer. When you get your negative b plus or minus square root all over 2a. So any questions on how you complete the square? So this is another technique you can use to solve quadratics. We use a lot of other applications of completing the square as well, besides just solving quadratics later on. All right, so any questions? Your favorite, long division. You guys remember long division? You guys did synthetic division? Why do you have to know long division? Does synthetic division work all the time? No, that's why you have to know long division. Let's just jump to problem number 2. Let's review. Remember, so if you want to divide 2 polynomials, remember, long division works all the time. Synthetic does not. Could you even use synthetic division on this example? No, you cannot. So remember, you take your divisor, 3x, it goes on the outside of your division sign, and you're going to divide it into the first polynomial. So remember the way the process starts. You start by dividing. We take 3x, and we divide it into 6x to the third. So I have to take 6x to the third and divide it by 3x. That's my first step. So what is 6x to the third divided by 3x? 2x squared. So that's what I'm going to fill in up top. So after you divide, do you remember what you do next? After you divide, you do what? We bring down, but before we bring down, what do we have to do with the 2x squared and the 3x? You have to do what? Multiply. So 2x squared times 3x is where I get the 6x cubed from. And then remember, what do you have to do? You're going to subtract. So the 6x to the third minus 6x to the third cancels. Now I'm going to bring down my 9x squared and my plus 3x. You keep going until you cannot take 3x and divide it into the first term evenly. You always work with the first term. So I need to now take 9x squared and divide it by 3x. So what is 9x squared divided by 3x? That's going to give me a what? 3x. So I add 3x at the top. And I repeat the process again. So what am I going to do with the 3x and the 3x? I'm going to have to do what? Multiply. 3x times 3x is a 9x squared. And remember, I'm going to subtract again. So the 9x squares go away, and again, I'm going to bring down my 3x. Again, I keep going until I can't divide evenly anymore. So now I have to take 3x and divide it into 3x. And what is 3x divided by 3x? 1. So I add 1 at the top. So 1 times 3x is a 3x. I subtract. So what's the remainder turn out to be? The remainder for this one turns out to be what? 0. So remember the process of the number. Kind of remember this a little bit from last year? All right. Let's take a look at. So remember, the steps that you do for long division, call it the family plan. You first start with a D. You have to divide. Then you got your mom. You got to multiply. So remember the steps for long division. You divide, multiply. Then you got your sister. You got to subtract. So we would like to subtract her out of the family, but we're not going to subtract her out of the family. And then you got the brother. So then we're going to bring down. Okay? So just a reminder just of how you do your long division. Okay? So let's take a look at number 3. I want to take x plus 7 and divide it into x squared plus 9x plus 14. So you always work with the first terms. I'm going to take x and divide it into x squared. So you always work with the first terms. So what is x squared divided by x? X squared divided by x is what? X. And I always like to keep my like terms lined up when I do long division. So I'm going to place my x over the 9x. I like to keep all my x squares lined up, all my x's lined up. Keep your work lined up. After you divide, what do? You're going to end up doing what? Multiply. So you have to distribute the x to the x as well as to the 7. So x times x is x squared. X times 7 is a 7x. So line it up right underneath the 9x. After you multiply, what's the next step? You're going to have to do what? Subtract. So remember, you subtract the x squared as well as the 7x. Distribute the negative sign all the way across. So x squared minus x squared cancels out. What's 9x minus 7x? 2x. So then I'm going to bring down my 14. I multiplied x times 7. Because remember, after you divide, you have to multiply. So you got to distribute the x to both terms on the x side. You go again. Always work with the first term. So now I have to take 2x and divide it by x. And what's a 2x divided by x? 2. So I'll write a plus 2 at the top. After I divide, what do? I'm going to multiply. So 2 times x is a 2x. 2 times 7 is a 14. After I multiply, I'm going to subtract. So what happens when I subtract those? I end up with a what? 0. So do I have a remainder? No. All right, so any questions on that? You guys go ahead and try number 4 for me. Yes, sir. Cancel? Yeah. Yeah, but we're just practicing long division. But you're absolutely right.